Okay, so let us take one more example. We would be taking other types of questions also in this chapter, but let us see what is happening in this now. In this question, prove that this is an odd number for all positive integers. So how are we going to do it? First of all, we write p of n is 2 raised to power n minus 1 raised to power n divided by 3. Now this is an odd number, so we can't assume it to be equal to something. Okay, we can say that it comes out to be equal to 2x plus 1, or you can assume it 2x minus 1 or something, because odd number is written like this: 2x plus 1. So now let us take go to the step number one. Let us substitute n is equal to 1 and see if the statement is true. So this 2 raised to power 1 minus 1 raised to power 1 divided by 3. So it is going to come out to be 2 plus 1 by 3. So 3 by 3 is equal to 1. And yes, it is an odd number. So our step number one is complete now. So step number two, which is an assumption, and here I am going to substitute k in the place of n. So pk is 2 raised to power k minus 1 raised to power k divided by 3. So this has to be proved. We have assumed it that this is equal to 2x plus 1. See, I'm going to erase this thing, otherwise it is going to confuse you. So this is now assumed. This is the assumption that we are now making. And now statement. So what is the statement? Now I am going to substitute it with k plus 1. So it is 2 raised to power k plus 1 minus 1 raised to power k plus 1 divided by 3. So now I am going to play some mathematics here. So this is, it becomes a step number 4 actually. Okay, so let us see what is happening here now. This will be 2 raised to power k minus, this can be taken as minus 1 and minus 1 raised to power k. So this will be divided by 3. So now what I do is I take some value from this place and I will replace the value of 2k from here. I am going to find the value of 2k. So uh, let us not take it 2x plus 1. It is a very big number. Instead, we just call it p. So p is an odd number. So this can be taken as 3p plus minus 1 raised to power k, and this I'm going to substitute in here. Minus 1 raised to power k. So this minus and minus becomes plus. So it is minus 1 raised to power k again divided by 3. We have to fight our way from these kind of mathematical equations. That is the only method available. So this step number 4 is a clear-cut arithmetics. We have to prove this thing somehow. Okay, so now what are we going to do? We just add these two. Yeah, so it will be 3 to the 6p plus twice of minus 1k plus minus 1 raised to power k divided by 3. So this will come out to be 6p plus 3 times minus k raised to power 3 divided by 3. So now we cancel this 3. So we are left with 2p plus minus 1 raised to power k. Okay, so this p, now we see this p is the odd number, and this number, you see, we know that when an odd number is multiplied by 2, it becomes even, and when either plus minus 1, if we get an even number and we add or subtract 1, either add or subtract, what we get is odd number. So here you see 2p is an even number, and plus minus 1 raised to power k, which could be 1 or minus 1. So it will be even plus minus 1. So it is definitely coming out to be an odd number. So this is how we do this question.